Insert in array. Insertion in an array refers to adding a new value at a specific position in the array. We know arrays have fixed sizes. What is meant by fixed sizes? All the positions in array are indexed. Each position will have an index starting from 0, 1, 2, 3 and so on. Here, each position will have a significance and generally we'll have the elements placed starting from the first position and placed in consecutive positions. This is how generally we'll keep the elements in array. Because of this, whenever you want to insert a new element, depending on the position of insertion, you may or may not have to rearrange other elements. The question is, when do you have to rearrange and what are the rearrangements to be done? This is what we are going to learn here. In insertion, mainly you need to learn what rearrangements you have to do and when you have to do the rearrangements. Let us put some numbers here. 12, 7, 15, 20. Let these be the numbers in your array. We'll take each case of insertion and understand what is the procedure. First case is insertion at the end. This is the simplest case of insertion. Whenever you want to insert at the end, let us say you want to insert 21 at the end. How can you insert? In this case, you don't have to disturb any other elements because you want to insert at the end of this. How can you insert? One thing, when I say end of an array, that means whatever be the position till which it is already filled, the position that is available after that. In case your array is already filled, then you can't do anything. Arrays, we are considering only static arrays. So in case your array is totally filled, you can't insert a new element. We are considering that there are empty spaces in the array, but it is filled only till some point. In this case, whatever be the next available position, that is what we mention as insertion at the end. Here, if you want to insert 21, it is very simple. You can directly insert 21 here. Then one question is, how did I directly reach this last position? It is because arrays have indexed access. If you know I want to access index 4, I can directly access index 4. This is how I directly reach this position. What is the time and space complexity of this? See, whenever we are learning any algorithm, any procedure, we have to know what is the time and space complexity. The point is, one is it gives a completeness to your understanding. If you are able to identify what is the time complexity, that means you are clear about the algorithm. So whenever you learn about any algorithm, you should always know what is the time complexity, what is the space complexity. I didn't mean you have to by heart. From the algorithm, you should be able to automatically understand what is the time complexity, what time does it take to run. Here, in case of time complexity, you are not using any extra time that is comparable to the length of the array. Here you are directly placing it here, which means time complexity is order of 1. It is constant time operation. You can directly go and insert it in the last position. What about the space complexity? Coming to space complexity, we only count the additional space that is used by a procedure. For example, in this case, you have an array here. The space that is occupied by this array, this is not counted. Even the space that is required for new insertion, this is also not counted because all this space is already existing. This is a static array. You are simply inserting the element into an existing position, which means you are not using any additional space here. Space complexity is also order of 1. So it is constant time and constant space operation. This is about insertion at the end. This is the simplest case of insertion. Let us go into the other cases. Second case is insertion at the beginning of the array. Let us say this 21 is not there and you want to insert 21 at the beginning of array. Can you directly insert it at the beginning? No, because that position is already occupied. What do you have to do? You have to make space for 21. Can you take this 12 and keep it here and then keep 21 here? Is this possible? No, the reason is in array we already told each position has its own significance. And whenever you say that these elements are present in the array, the order matters. You always consider that whenever you want to do an insertion or any operation on this, you should preserve the order of elements. Because of which you can't simply pick 12 and keep here. Instead, you will have to maintain the order, which means all the elements have to be moved one position towards right. This way, you can make space for 21 in the first position and then 21 can be inserted. What will you do here? 20 will be moved here, 15 will be moved here, 7 will be moved here, 12 moved here, and then now that you have space for 21, you can insert 21 here. This is the procedure for insertion at the beginning. What is the time complexity of this operation? In case the length of array is n, what do you have to do here? All the n elements have to be moved one position towards right. When you're moving all of those, that means time complexity is order of n for this operation itself. When you want to move all the elements one position towards right, you are going through each of the elements in the array. It will take order of n time. After that, once the moving is done, you can directly insert 21 in the first position because it is empty. So total time complexity of insertion at the beginning is order of n. See, whenever we talk about insertion or any operation, when you are talking about time complexity, always think about worst case time complexity. Okay? And what is the space complexity here? You are not using any additional space. This array is already existing. It is not newly created as part of insertion, because of which space complexity is order of 1. So it is constant space operation. This is it about insertion at the beginning of an array. Next is insertion at a specific position. We already discussed two special cases, that is insertion at the end and insertion at the beginning. Next one is, instead of this, if you want to insert at any specific position, then what is the procedure? Here let us say this 21 is not here and I want to insert 20 is not there and I want to insert 20 at position, let us say some particular position. I want to insert at 2. 2 is the position at which I want to insert 20. This is the requirement. How can I insert 20 at 2? Can I directly insert 20? No, because the position is not available. What will I do? I have to move the elements one step towards right. Should I move all the elements? No, that's also not required because I have to insert 20 at this position. I need not disturb any of the elements which are existing before this position. So 12, 21 and 12 that are existing before the position 2, those need not be disturbed. I only have to move those elements which are to the right of 2 and at 2. These are to be moved. What will I do? All the elements will be moved one step towards right. When I say all the elements till this position. After that, these elements you need not move. What will you do now? 15 will come here. 7 will come here. After that, you can insert 20 at position 2. This is the procedure for insertion at a specific position. In this case, what is the time complexity? As I told you, whenever you are thinking about time complexity, think about the worst case. What can happen in the worst case? See, in the best case, this position can be the last position. You need not move anything. You can directly insert. But this is not what you want to consider while analyzing time complexity. Think about the worst case. What if your specific position is the beginning? What if 0 is the index you want to insert? In this case, you will have to move all the n elements one step towards right. So this is the worst case scenario, and in this worst case, Time complexity is order of n. All the n elements have to be moved. Time complexity is order of n. What about the space complexity? Space complexity, this is a static array. You are not using any additional space. So space complexity is order of 1. What did we learn now? There are 3 cases. One is insertion at the end, insertion at beginning, and insertion at a specific position. For end, we saw that time complexity is order of 1. Space complexity is also order of 1. What about insertion at the beginning? Here time complexity was order of n and space complexity order of 1. What about specific position? Time complexity, we saw it is order of n and space complexity is order of 1. Next thing is, let us write a pseudocode for this. Why I am writing pseudocode is, if you want to implement this, if you want to write a code, it will be easier for you to convert pseudocode into a code. Here I explain what is the procedure. Still, in case you are finding it difficult to implement, I'll give you the pseudocode from which it will be very easy. This is why I want to give you a pseudocode. Let us go to the pseudocode and understand how to convert this into a code. Whatever I said, whatever is the procedure, let us see how will it work in a code. Insertion. Let us say you want to insert at some specific position. You have an array. This is the array. You have length of array. What is the length of array here? Till whatever position it is filled. That is what I am calling as length. I'll also have capacity. So capacity is the total size of array. Let us say this is your static array. Here capacity of this array is 6 because there are a total of 6 positions available in the array. What is the length of this array? By length I mean whatever are the filled positions. Here there are 5 positions that are filled. So as of now, the length of array is 5. The point is, length can change when a new element is inserted or deleted. But capacity will remain the same. That is the total size of the static array. Okay. Length, capacity. Then you want an element. This is the element to be inserted. Whatever you want to newly insert, that is what I am calling as element. One more thing is, I should know what position should I insert. Position. These are the required arguments for your function. Let us see what are the steps to be followed. First thing is, whenever you want to insert, in case the array is already full, you can't do anything in this case. Here it is a static array. So if it is already fully filled, you can't insert a new element. You have to abort. What can you say then? In case if your length is already equal to capacity. In case this is also filled, let us say this is the scenario, then you can't insert a new element. It is a static array. So in case your length is equal to capacity, you can't insert. Let us say you will return -1. Return -1 is showing that the operation is not possible. Okay. Now that you know operation is possible, what can you do? If this return is not done, that means there is space available in the array. Next check is, whatever be the position to be inserted, this should be a valid position. This is important. How can you check whether it is a valid position? If it is a position after the length, if your length is 4 and you want to insert in this position, index 5, this is not valid because generally you won't leave empty spaces in an array. You want to keep in consecutive positions. Similarly, if I am saying insert at -1, there is no position called -1. The least is 0. That is also invalid. What will you do here? If position is lesser than 0 or if position is greater than length. In both these cases, what will you say? You will say it is not possible. Return -1. This is invalid position. Why is it not greater than length -1? You may have this doubt. That is, it is 0 indexed, which means from 0 to length -1 are the available positions. Why am I writing greater than length? The reason is you can insert at the end of the array. That means after this length minus 1, it is possible to insert in the next position. That is why it is greater than length and not length minus 1. After this, in case it is not returned, you know that there is space available in the array and there is the position that is provided is a valid position. What can you do now? You can proceed with insertion. For insertion, what is the procedure? All the elements starting from that position till the end, all of those should be moved one step towards right. Here, you have to keep one thing in mind, that is, you can't start this movement from this position. Instead, you have to start from the end so that space is made for moving each element. That is, if you move this element, then only the previous element can be moved to this space. What can you do now? When you are looping through, you have to start from the end of the array and do it till this position. For, I'll write a for loop here. For I is equal to, what is the last position? It is length minus 1. From length minus 1 to whatever is the position you have to insert. Till the position, what do you have to do? You have to move each element one step towards right. How will you move to one step towards right? You will say a of I plus 1 equal to a of I. You are moving it one step towards right. After this loop, you have moved all the elements from that position till the end one step towards right, and now you have position to insert. You have space to insert in the position. What will you do now? Array of position is equal to the element you want to insert. At this point, insertion is done. Next thing is, the length of the array should increase given that you have inserted a new element. What will you do? Length is equal to length plus 1. You increase the length of the array. Now all the procedure is done. You can return array. This is the algorithm. Let us just go through this once more. For insertion, you are having array, then the length of array, capacity of array, which is the total size of your static array. Then you have an element to be inserted and there is a specific position. What are you going to check? First, you will check whether the capacity of array is already completed, whether it is already full. In that case, you cannot insert. If it is not the case, then you will verify that the position to be inserted is a valid position. If that is valid, then what will you do? You will move all the elements from the position till the end. All of those will be moved one step towards right. After this, you will have space to insert. You can insert the element, increase the length of array and return the array. Here, in all the cases that we discussed, that is end, beginning and specific position, all these are covered in the same algorithm. See, the reason why I taught you as 3 different cases is, I wanted you to start from the simplest case, which is insertion at the end, and understand that in each cases, this is the scenario. Now that you know what is each scenario, all can be clubbed into the same algorithm. So in this case, if you give position as 0, it will work for insertion at beginning. If you give position as length, it will work for insertion at the end. That's it. This particular algorithm will work for all the cases. Everything is covered here. Just that while we were learning initially, we took each case as separate cases and learned about it. So in case of insertion, what is the time complexity here? Time complexity is order of n and space complexity is order of 1.